Yeah. So now here we are using RDS. RDS is the relational database service. It's supporting SQL kind of databases. SQL stands for structured query language, and most of them we have the relational databases. Other than that, we have like a NoSQL kind of thing, or document base also we have. Okay, what are those differences we'll discuss, and we are going to create here the DB instance. Can you go to the DB instance? And if possible, can you maximum that? Is it the complexity? Okay, yeah. So go to DB instance, create the database. So create the database there. So now here we have a requirement. One application team asks the database. We are going to design the networking, encryptions, backups, storage options, auto scaling, which engine we want, updates, rollbacks, snapshots, all these we need to take care. Okay, so these all previously the database administrator kind of job role, but nowadays we don't have any separate DBA. This is also part of our AWS job role itself. Okay, coming to this, here we have standard create option, easy create option. Better to go with the standard itself. Very, very important. What are the engines we have supported? Almost we have 6 to 7 engines we have. Aurora. Aurora is having two engines as of now. One is MySQL compatible and Postgre. Now, who is managing those Aurora database? Aurora is AWS managed itself. And we have MySQL, Postgre, MariaDB. MariaDB is also is a fork of MySQL itself. What is the meaning of fork of MySQL is just like in the Linux, we have the different flavors, right? MariaDB is also is another flavor of MySQL itself. Then we have Oracle, then MS SQL Server, IBM DB2. Among these, can you tell me which of the licenses, license one?
Maybe
In this, which databases are licensed and which are open sources?
IBM is a license.
Yeah, IBM DB2 is licensed one. Oracle also is there. MS SQL Server also is licensed. Then Aurora, Aurora Postgre, MySQL, Postgre, MariaDB. So these all open sources. So you try to choose maybe MySQL. Okay, so in the production, we maybe for dev and QA environments, we may use Aurora, but production people prefer to use MySQL itself. Okay, then what is the MySQL version we are getting here? So make sure for each and every database engine, what are the port numbers and what are the versions we have tried to go through once. Okay, so here as of now we are choosing MySQL. What is the version we have is by default we are getting 8.0.41. Previously we have 5 also, but that is end of life almost there, or we can use even still 5.7 point some version is there, but take it 8. Okay, so then scroll down, we can take the support also from this. Then for the template, we can use production. Don't choose because it's very expensive kind of thing, because they're going to give, say here we have two options, right? Single agent deployment, say choose the production itself. If I choose the production, so now here we have 3 types of architectures. Single agent is not suitable for production workloads. Maybe for the small environments or for the dev QA environments itself. Meaning of multi-agent DB deployment. What is this meaning is we are keeping in the multiple zones. Multi-agent stands for multiple available zones. One where we are keeping a primary instance and we are keeping a standby instance. By default, a replication activity is going to happen. And if the primary instance in one zone goes down, automatically it's going to switch to secondary zone or standby. But here instead of this, we can set up a we can set up the MySQL cluster also. Okay, so in this, we'll have one primary instance and we'll have the standby like read replicas kind of thing. And all we are running in the multiple zones. Even if the primary cluster, like one zone goes down, the solution is highly available. Okay, so what is the uptime they're promising? 99.95 uptime is promised by the AWS, and even some read replicas we can replicate to other region also we can replicate. What are those read replicas also we'll discuss. That means whenever you are telling on the production databases, we should tell we have a multi-agent DB instance is one method, or DB cluster is one method. Okay, for the very high-end application, not only two engines, we have more than 10 to 15 engines we have, then better to go for the third option. For the medium kind of enterprises, better to go for the second option. But as of now, don't go for those. You choose theater eligibility. Okay, just scroll little up. Okay, yeah, please scroll up little up, not down. Go to that free tier eligible itself. But just explore these options, all those options. But while creating, go for free tier itself. And once your work is done, everyone delete the instances also. Yeah, choose the free tier, scroll down. Then we are going to choose only single agent DB, and we need to give the database name based on your project. You can give any of that, like a database name you can provide. Give any DB name, maybe Clouds of DB like that, or Clouds of MySQL like that. You can give one name. Okay, so once you given the name, yeah, master username you can give admin also is fine. Okay, and in the real time, like going forward, we'll discuss for the production databases, they don't give the databases directly the password. They're going to use AWS Secret Manager or maybe HashiCorp Vault, or they're going to use, if it is Azure, Azure Vaults, they're going to keep. And from that, we are going to get those details. Okay, and set the password also, make it complex password. Make a complex password. Okay, so once we set up the password, we need to choose the instance configuration. As of now, what is the instance? db dot t4, right? No, scroll, come down. Because they will charge more amount also for that. If it is t2 dot micro, then no problem. Okay, and storage also. So we are choosing general purpose GP2 or GP3. For the production, we shouldn't choose, maybe GP3 is fine, but for the high end, we need to choose IO2. But here, don't choose that IO2. We choose GP2 or GP3, and 20 GB we can choose. And even the storage automatically scale up also we can set up. Automatic scale up also we can configure. So mostly when we are designing the networking part, it's mandatory the VPC we need to choose in the which subnet we need to choose.
Private.
In the private subnet itself, we need to choose. As of now, whenever we want to keep it, we need to choose in the private subnet. Okay, so then if you want to connect from that using the IPv4, like connect to the EC2 instance, you can choose. Connect to EC2 compute resource we can set. and choose the subnet should be mandatory in the real time. Maybe subnet should be. So that is also, if you don't want, you can restrict that. So keep don't connect itself. Okay. So then we need to choose the subnet and like all that VPCs, all those we need to choose. So as of now, go with the default, but in the production, we need to go for, okay. And subnet group, I will explain DB subnet group. Public access, do you need to provide the public access? Yes or no? The public access we need to provide or yes or no? So we shouldn't give the public access to the database. Giving the public access is very, very dangerous. Okay. So we shouldn't give the public access. No. Okay. And better to create a new security group. And that is the reason we need to know the port numbers for all the database engines around. We have 6 to 7 database engines, right? Like MySQL, IBM DB2, Oracle, okay, SQL Server. For all those, we need to know the port numbers we need to know. So we need to know the port numbers because any of that port numbers people will ask us in the interview. Okay, so that's any idea what is the MySQL port number? Any idea what is the MySQL port number? MySQL port number is 3306. Okay, so MySQL port number is 3306. Even if I use Aurora MySQL also, it's 3306 itself. And for the Postgre or Postgre engine or Aurora Postgre, the port number is 5432. Okay. Then in the security group, it's mandatory. We need to open those port numbers. Okay. Then MariaDB, again, MariaDB is a MySQL itself, 3306. Okay. SQL Server is 1433. And Oracle is 1521. 1521. Okay, and if we use IBM we are using IBM DB2 is around I think 5,000. Those all we need to open the port numbers. Okay, so then like here we have one more option like RDS like a proxy we have. So we can choose even the RDS proxy also if you want to create an RDS proxy like only for the Aurora for those itself it improves the scalability all that. But as of now we are not creating. So we have a very high scalable application. We are going to choose RDS proxy also. Okay. So MySQL, MariaDB, Aurora, Postgre, for all those, it is supporting like a proxy. Okay. So then choose next option. Certificate authority also for the certificates we can go. Then, yeah, go with the 3306. Yeah, scroll down. The password authentication itself, we need to set the passwords. Yeah, say suppose here for the production, definitely we need to enable the monitoring, logging, all those also we need to set up. All these also we need to set up those. Okay, so as of now, don't configure all those. And additional options also we'll see. Yeah, as of now, we are in the free tier eligible itself. Yeah, go and choose that. No need. Initial, yeah. Say here by default we'll get the databases. Your application also we want any database for your project. That database after creating to the MySQL, we can create that. Okay. Yeah. Next. Yeah, click the submit after, go with the, no need of backups also. For the production, we need to enable the backups. Okay, so as of now, no backups also. Yeah, create a database. This itself may be creating a MariaDB, Postgre, these are manageable, but Oracle, all these require a lot of expertise kind of administration, and MySQL also setting up the DB clusters, all those are the not easy things. Say it takes 5 to 10 minutes. Okay. So now in the same way, we created the different engines, try to create. After that, even try to delete also. Don't keep those engines for longer period and don't keep very high-end kind of production clusters. All those don't create because your account would be affected with that. And you should be very careful to delete those engines also once you start. Set in the real time, you don't get the opportunity to work in all the engines you don't get. Here, try to practice all the engines. For the multiple times, assuming they require the multiple databases, assume like that and create those databases. Okay, come to again the services, you come back. They let it create, it takes some time. Come back. No, complete to the services. Complete to the services. Search for the service called Elasticsearch. Search for the service Elasticsearch. So Elasticsearch also will give us two engines. Say suppose my application required maybe Memcache or not that. Not that, that is OpenSearch is different. Elastic Cache, sorry, not Elasticsearch. Search for Elastic Cache. Yeah, go to Elastic Cache. In the Elastic Cache, we have two types of engines are there. What are those? So one is Redis Cache. Second one is Memcache. Okay, so that go to Memcache or Redis caches. Just scroll up, little up. Yeah, get started. So suppose our application team required these also, then we are going to create all these. So now they have added one more also. Okay, so it depends upon our project. We need to choose. Okay, say choose Redis. Yeah. Then Valky may be their own managed kind of thing. If they are recommending, meaning is mostly that's maybe their own managed kind of, just like Aurora we have, they may be added this also. Okay, so try to choose Redis OSS itself. The remaining all the options mostly the same thing, but what is the challenging thing is you take an EC2 instance. On top of that, you try to set up Redis, Memcache, Postgre, MariaDB or MongoDB. All this first try to install on your instance. Even if you don't get 100% success also, previously we used to do like that. Now what we are doing? We are using managed services. So we are using managed services. Okay. Yes, choose with the default options. New cache, give any name for that. My Redis cache is something. Yeah, go with the default engine itself. Engine version. That means what we are trying to do is depends upon our requirement. We are creating all this, but as of now, we are creating through the GUI. But going forward, what we need to do? So going forward, all these we need to create through the Terraform itself. Okay. So what is the expectation is we should able to create all these through the Terraform we need to create. Okay. That you no need to create all these, just explore all these options. Okay. So come back, cancel, go little up, search for Documento DB. Documento DB. Yeah. So what is the Documento DB is? Say normally we have MongoDB. From the similar MongoDB kind of compatible database, AWS is providing us for that document DB. Okay. Say MongoDB is also one of the NoSQL kind of database. Okay. But we don't have exact MongoDB version is not supported. Okay. So if any of the client asks us, they want MongoDB from the AWS, what we need suggest? What we need to suggest to the client? So we need to suggest to use the document DB. Amazon document DB, we need to suggest to the client. Okay, so try to create this also. But before doing all this, like what we need to do is, okay, so we need to create all these on your instances, try to practice. Okay, that means before cloud, we used to do all that. After moving to the cloud, we are doing in this way like that, we need to tell. Okay. They try to create here the Documento DB clusters also. But before doing all this, directly using these are very simple. First, try to take an EC2 instance. On that EC2 instance, try to install all these. Like you can use the help of ChatGPT also. And from this, we can manage all these. And come to one more service, come to Documento DB, sorry, DynamoDB. What is DynamoDB is, that DynamoDB is a serverless database. You no need to worry about the backend RDS instance and all those. Directly here you can use the tables and all that we can use the tables. It's an NoSQL kind of database and it's a distributed kind of thing. Okay, and global kind of service. And we can use DynamoDB. Okay, so for our NoSQL kind of serverless applications, we don't need to go for a very expensive RDS kind of things. The simplest solution is we can use DynamoDB. In the previous session, what we have done is we took an RDS. On top of RDS engine, we have installed our database. On top of that, we are using our own applications we are running. But in that, we can have the tables, all those we are going to set up. But in the DynamoDB is not giving us any server also. It's also very high scalable kind of thing. But lot of companies at the startup kind of thing, they don't have much user base. For that, we are going to use directly the tables we can create. Okay, only for the tables itself, like it says, suppose I got in a year, I got only 1,000 users. For that, maintaining a RDS kind of database is very expensive kind of thing. Okay, so that's in order to avoid these kind of things, we are going to use DynamoDB. They just try to create different tables. Normally, these all will create at the DDL level. We have the SQL commands, and at that level, we are going to create all these database schema structure. Okay, but if I go for a serverless, what is the database we are using? DynamoDB. Is it a NoSQL kind of thing or SQL database? DynamoDB is a NoSQL. What is the difference between an SQL and NoSQL is like SQL, as the name suggests, is a structured query language. Okay, so now here we have like EF card. Okay, so EF card is one of the father of database. Okay, so that means he is called as a father of database. Okay, so then a structure like he suggested around 12 rules for any of the database need to follow, and minimum if any database follows around 6.5 to 7 rules, that database is called as a structured query language. But today in the modern applications, even we are not following all the guidelines, NoSQL kind of databases also is getting more popular day by day. Okay, 1 second. Yeah, hello. I'm sorry. Say suppose these all the different engines. Say suppose you may want Elastic Cache or Redis or RDS. We have almost 7 engines. Or even for a serverless, we need to go for a database. Okay. So these all we are going to set up on AWS. For our applications, we shouldn't keep on the EC2 instances. Okay. So just go through. I'll share some more videos also related to S3 and DynamoDB. Next week, completely I'll show the lab itself for all these. Okay, next week I'll focus more on the lab itself. But try to navigate these all the services. Spend minimum 3 to 4 hours of time in all these. Spend the time. Okay.
Okay.
I'll share some videos also. Those also finish parallelly, and LAMP setup also everyone make it. LAMP is a very old tech stack, but one of the leading tech stack in the world at some one point of time. Okay, 90% of the websites used to deploy on the LAMP stack itself. But today a lot of advanced technologies came. Okay, but we need to practice the LAMP stack also. Okay. I'll share for DNS and S3 buckets also. Those also finished. Then next week I'll try to finish all these labs hands-on well finished. Okay.
So that's you are starting from Terraform and the tools.
And next week parallelly we'll start with the DevOps tools also.
Okay.
So, AWS 45 minutes, DevOps tools 45 minutes, like that we'll discuss.
Okay.
Okay, sure.